Okay, so for tomorrow's assignment that we had handed out yesterday that dealt with calculating atomic masses and writing out formulas, you can see we left on the board where we left off with yesterday. And should you be given a chemical formula, then you write out the name. Should be given the name, you write out the chemical formula and calculate its atomic mass. So, where we left off with yesterday is we have calcium chloride here. What we would do is write out the symbol for calcium, which of course is Ca. And the symbol for the chloride ion would be chlorine, but since it's in ion form now, it's Cl. We put the charges up there, begin with your negative ion, which is -1. Calcium is in column 2, so it's +2. The least common multiple between them then is, of course, 2. 2 divided by 1 gives us 2. 2 divided by 2 gives us 1. So that would be the correct formula for calcium chloride. And we don't need to write Roman numerals for all positive ions because we know what the charge for calcium is. Unlike elements like tin and copper that have multiple charges. Iron only has an oxidation state of +3. Aluminum, Cobalt can be +2 or +3, but calcium can only be +2. So that's why you don't see a Roman numeral 2 after the calcium. So as we proceed forward then, the atomic mass of calcium, I do believe, is 40, and 1 chloride ion is 35.45. So this is around 70.90. So 70.90 plus 40 then would give us our 0.900, around 110.90 grams for calcium chloride. Then as we proceed forward, the symbol CO is for cobalt then. So cobalt, we're going to leave a space between there because we know that cobalt can either be a +2 or a +3. So we'll leave that space. NO3 is the nitrate ion. Okay, and remember we said begin with your negative ion, which nitrate has a -1. -1 times 3 gives us overall charge of -3. So therefore, cobalt has to have a +3 charge. So therefore, this would be cobalt-3 nitrate. Then we add together the atomic masses for all of those ions, which cobalt is 58.93 and nitrogen is 14. So we take that times 3 because we have to distribute this 3 through here. So 1 cobalt is 58.93. This is 14. 14 times that 3 then gives us 42. And then we again distribute this 3 through here. And 3 times 3 gives us 9. And for every oxygen, which is 16, 16 times 9, then give us, I believe, 128. 16 times 9, 144. So it's mistaken, 144. Add all them together. That's cobalt-3 nitrate then. Okay, so with this one, oxygen, okay, well, let's write out what these stand for. First of all, Fe is iron, okay, and O is the oxide ion. Again, we're going to leave a space because iron can have a +2 or a +3 charge. So, beginning with our negative ions, 3 times every oxygen is -2, so therefore that's -6. So this has to add up to +6. So, with that being the case, we know that the least common multiple, how we got to that would be 6. 6 divided by 2 gave us that 3. So 6 divided by 3 then would give us that 2. So that being said, that means this has to have a charge of plus 3. So therefore we have iron 3 oxide. And 1 iron is 55.85. We've got 2 of them. And then every oxygen then is 16. 16 times 3 gives us 42. Adding those together. Let's see here. 10, 1, 16, 17, 1, 11, 12, 13, 14, 10, 14. That doesn't look right. Trying to get this done in a hurry is part of the problem. So we've got 55.85 times 2, and then plus 42. That's part of the problem. It should be plus 48. One should be 159. Yep. That's not 42. That should be 48 on account of every oxygen 16. 16 times 3 would give us 48, so that would be 159. 159. Okay, and then to help us out on that front side of this paper, we see a compound known as ammonium. Okay, so looking at that, I'm guessing that some of us do have a head start on this. Maybe not everybody, but we still have time to work on those. So on that front side, we see this. It says ammonium carbonate. Okay. And the formula for the ammonium ion is NH4. It's got a +1 charge. And the carbonate ion we know is CO3. Okay, we always said go by your negative ions, which this is -2. Those charges do not add up to 0. Least common multiple between them is 2. 2 divided by 2 gives us 1. We've got 1 cobalt ion, therefore 2 divided by 1 gives us 2. But we don't want 42 hydrogens. We want 2 ammonium ions. That's 1. So to make that 2 ammonium ions, we put that in parentheses. Then we've got 14 times 2. So that's 28.02. 8. 2 times 4 gives us 8. Times 1.01 gives us 8.08. 1 carbon, which is 12.01. And 3 oxygens would give us 48. Add them together, that would give the atomic mass for ammonium carbonate. And in this upper right hand corner it says AgN with a lowercase 3. This is what that should look like. Should have a capital letter there. Again, that's for this one in the upper right hand corner on the front side. Looking at the back side, let's just go ahead and pick one of these. We'll do beryllium hydroxide. Beryllium hydroxide. Okay, so the symbol for beryllium is Be, and the formula for the hydroxide ion is OH. We know that the negative charge for this is -1. Beryllium is in column 2, so that's why we don't see beryllium 2 hydroxide here. Column 2, +2 charge. That does not add up to 0. So therefore 2 divided by 1 gives us 2. This is 1 hydroxide ion, but again we want 2, and 2 divided by 2 gives us 1. So therefore we add up 1 beryllium ion, 32 for the oxygens, 16 plus 16 because of that 2, and then 2.02 for that. So 32 for the oxygens, 2.02 for the hydrogens, and beryllium is approximately 7 maybe? No, 9.01. Okay, So then 9.01 for the beryllium ion. Adding those together, 13, 1, 43.02 for beryllium hydroxide. So should you have any problems, please get in and talk to me, and we'll give you some in-class time tomorrow. So we will address this once you arrive tomorrow. Till then.